Now coming to padding. So why padding is needed? Actually, whenever we are giving 6 by 6 input image, after applying convolution, we are getting 4 by 4. So that means there is a little bit of information loss. So for that purpose, we will use padding. And again, for example, if we are not going to perform single convolution, this is convolution layer for suppose, we will be applying multiple convolution layers, and then again we will be using max pooling. So after applying so many convolution, the input size is 6 by 6. Now after applying one filter or one convolution, we are getting 4 by 4. So after applying several, it will diminish, like the dimension will be reduced to little lesser than the whatever given in input pixels. So that's why if you want to get the same pixels or 6 by 6 as output also, we can apply padding. Again, for data augmentation we can perform, and again many more as per the needs, problems and solutions. Based on that we will apply. And again, information loss is there, so that's why we are applying, because we are giving 6 by 6 and we are getting output as 4 by 4 only earlier here, but we are detecting feature, but the output is reduced, like information and or data has been reduced, right? And again, we can also argue, like after adding as you can see, after adding edges we will be getting additional edges also. So if we are getting more data or more information which is not there, but by our by applying padding we can say that this information is unnecessary. So we can also treat that as information loss only, because if you are getting unnecessary data, that's again loss of information for useful data. So I think you got it. For example, now we have we need, this is the input image, right? 6 by 6. We need to add row, top of that, bottom of that, and one column, left side, right side. So we have to just construct a boundary like thing using padding. One means only one cell, one row up, one row down, one row left side, one row right side. That means padding 1. And here to fill the values in the padding, we can use 0 1 padding. 0 padding, most common technique. 0 1 padding is common technique, so we can just fill zeros over ones over there, and mostly zeros are used. And again we can use nearest like padding, like here we have nearest cell is 0. Using BFS DFS we can find, or other technique we can find. Here we have nearest cell as 1, so based on the input image, whatever the nearest, we can just fill that padding over here. For example, here nearest will be 0, and we can take probability or how many of them are nearest. Like if you have 2 0 cells as nearest and one nearest cell is 1, because for this is nearest, and this is only this also nearest, but 2 0 are nearest, so we can just keep 0 instead of 1, because both are at the same distance. If we take unit 1, if we take adjacent cells to be unit 1, adjacent cell in the sense, if we have this thing, and mostly we will not be having above thing, because we are padding applying based on the input image. So we'll just be focusing on these 3 things. So these 3, this is nothing but if we take r comma c, so bottom one will be what, r plus 1 comma c, and this one will be what, r plus 1 comma c plus 1, and this one will be r plus 1 c minus 1, and this one will be, we are just we have to take probability based on this only, mostly because it is a middle limit. And again I'm just showing this one, showing this coordinates, like this will be r comma c minus 1, and this will be r comma c plus 1, and this will be r minus 1 c plus 1, this one will be r minus 1 c, and this one will be r minus 1 and c minus 1. We will be just focusing on these things only. So we will just take whatever the maximum. If this is 0, this is 0 1, we will vote 0 has more votes, so we can just give to 0. And again other techniques can be used. Probability based method can be also used, which is having more probability. So yeah, again we are applying filter, vertical edge detector filter for example. Now we will get result like this, and again we will get result over here also. So we will get 6 by 6, 4 by 4. Again as a padding result we will get 6 by 6, because the formula is something like this now, n plus 2p minus f plus 1. So then we will get 6 by 6 if you will apply that. Again we are just increasing the size of the input image to 8 by 8. So as per 8 by 8 it will get 6 by 6. So, and again edges are increased, as you can see here, this edge is there. So because 1 and 0 are differentiated by this thing, that will be differentiated, that will be shown over here, and this is absolutely there. And again this one is there. So 3 vertical edges, and here one horizontal edge, one second horizontal edge, here this is not n because these are just combined ones, but here we have different 0 1, so that means we have differentiating border over here. So that means 2 horizontal edges we have found and 3 vertical edges, but in the image, as per the image, we should have only one vertical edge as we have seen earlier. But sometimes this information will be useful, sometimes it won't be, but mostly like if you don't want to lose out the information or data from the input image, like if you don't want to reduce the dimension from 6x6 to 4x4 earlier, so we can just use padding, so that it will be converted to 8x8, and after applying filter convolution operation, if you do, you will get 6x6 again. So, and again we will not lose information. And again, sometimes if you have more edges, information loss will be there, because if you are getting unnecessary information or not useful information, so that will be directly related to loss of information itself. If you get it, it will be directly like directly proportional to loss of information only. If you get unnecessary information, and that will be directly related or proportional to loss of information only. And again, if you apply so many layers, then that edges will be also scrutinized, and we cannot perfectly get this single edge also, because we are not losing out pixels, right? So we can apply different convolution layer. After that, we will get the features will be accurate enough compared to previous results.